Ask my instructor 6.4.49. A hemispherical bowl of radius 7 is filled to a depth of h inches. Use the shell method to find the volume of water in the bowl as a function of h. The first order of business is positioning our bowl. For the disk method, I would put the bowl on its side and rotate about the x-axis. But for the shell method, rotating about the y-axis is easiest for me. Where to put the x-axis? Well, this seems the most natural, but algebraically speaking, I don't really want it there. I prefer to have the x-axis there because then my circle is centered at 0, 0, and the equation of my circle is as simple as possible. The reason why I want to do it that way is I want to, as I said, I want to have this equation of the circle simple because I have to solve for y, and that's going to be ugly enough as it is. So I solve for y and I get plus or minus, but I use the negative possibility because the piece of curve that I'm interested in is below the x-axis. Alright, next, where does how high, like I can see that my depth is h, but where does the top of the water hit the y-axis? Again, because I'm below the x-axis, I go down to negative h and then go up, I go down to negative 7 and then I work my way up h units. So the top of the water hits the y-axis at h minus 7. Recall the volume of a shell is circumference times height times width. So I need to find those three components. But I also need to find my range of x. X is non-negative because I'm rotating about the y-axis. So the range of x starts at 0. How high up does it go? The temptation is to say it goes up to 7, but unfortunately, unless the bowl is filled to the top, it won't. It'll go to the curve. Alright, so what is the length of this blue line? The length of the blue line gives us the upper bound of x. And that involves the Pythagorean theorem. You're going to have to use a little bit of algebra there as well. And I get this for the length of my blue line. And that gives me, as I said, my upper bound. Okay, so I have the range of x. Now let's fix a value of x. For a given value of x, what is going to be the range of y? This is the range of y. And so the height of my shell is going to be the difference of these two values. Here is my height. After I find the height of my shell, I'm going to find the circumference. To find the circumference, I need the radius. Fortunately, that piece is easy. And the circumference is just 2 pi x. At least there's one simple thing about this problem. The width of my shell is dx. Alright, if I have the height and the circumference and the width, I'm ready to find the volume of my shell. And this is what I get. add up all my shells, and the volume of the water in the bowl is given by this integral. Notice the bounds on x. That was where we had to find the length of that blue line. And we're finally down to finding this integral. I think one thing that makes this problem so hard is we don't know what h is. If we knew what h was, I think it would be a little simpler. Alright, so I pull out the 2 pi and I distribute the x, and I now am going to find the antiderivative. I find the antiderivative. Next, I'm going to evaluate it. And if you get a really long, messy answer, don't be surprised. This is what I get. Now, if you have something squared and then raised to the 3/2 power, that's just that same thing to the 3rd power. So use that to your advantage. So far, this is what I have. Still non-trivial. Now, you're going to have to take 7 minus h, raise it to the 3rd power. So you're going to have to find this binomial. And then there's a lot of algebra and cleaning up. When you're all done with the algebra and the cleaning up, this is the volume of the water as a function of h.